Today we are going to be graphing rational functions. Let's start this off by exploring what does a very basic rational function look like, and then we'll use that to graph more complicated ones later. So we're just going to graph this using a table. Let me do x and then f of x here. Of course, f of x is 1 over x, right? So, and I'll just take, let's do quite a few numbers here, just around 0. I'm going to go -4 to 4, and actually I might even throw in a couple other numbers, leave a little space there. All right. Okay, so what this tells us to do with the input is we divide 1 by our input, right? So if I put in -4, for example, I might not write this out every time, but just this one time. So you're going to put in -4, and you get -1/4. Or we're going to just go ahead and write it as a decimal, so -0.25. So let me put that in my table. Okay. If you put in -3, you're going to get -1/3, or approximately -0.33. I'm going to go ahead and just approximate that one. And then 1 over -2, that would be -0.5. 1 over -1, that would be -1. And then 1 over 0, well, that you can't do that. You're going to have, that's undefined here. And we'll see soon what that looks like on the graph. All right, and then 1 divided by 1 is 1. 1 divided by 2 is 0.5. 1 divided by 3 is about 0.33. 1 divided by 4 is 0.25. All right, so let me graph these just to see what this would look like. Now, so -4 and -0.25 about right there, and then -3, -1/3 here, or 0.33, just a little bit further down. And then -2, -1/2, right? And then -1, -1. Okay. It'd be nice to get a little bit more detail here. So let me go ahead and throw this in. I'm going to put in -1/2, or we can think of it as -0.5. 1 divided by -0.5, well, that's going to be -2. Okay, so -1/2, -2. All right. And now let me, 0, of course, nothing gets plotted. And then also let me throw in +1/2 here. If I put that in, I'm going to get +2. So 0.5, +2. And then 1, 1. 2, 1/2, 3, and up 1/3 here, and then 4 up 1/4. Okay. All right. So what we end up getting is sort of these two separate curves. Yeah, we could have put in more points or use our graphing calculator to see, that these actually never quite hit the axes. Okay, they sort of approach the axes and never quite hit them. Okay, and we'll talk a little bit more about that later. But this is what it looks like. Now we're going to use some of these points as reference points for when we graph the transformed functions. Okay, so I'll kind of come back to that. But that's just what a basic rational function looks like on a graph. Okay, let's graph something that has a transformation in it. So we have this f of x equals 1 over x minus 2 plus 1. So I can at least say f of x, but we're going to go ahead and sort of write a generic transformation form. I like to use g of x for that. F of x is usually used for a parent, but my program that I use for these doesn't let me change that to g. All right, anyways, the transformation form, there's a couple different ways we could see it. We'll have a over x minus h plus k. So a is the vertical, indicates a vertical stretch If it's negative, it shows a reflection over the x-axis. H indicates that there is some kind of shift left or right. Okay, so I might just go like this. And then K indicates that there's some kind of shift up or down. So let's look at this one. Now, usually when we use transformations to graph something, we need sort of a central point. Well, you might wonder, what is the central point here on this graph? Well, we're actually going to use the origin, even though that's not on the graph, but we're going to kind of use that as a reference point, or this anchor point that'll we'll get all of our other points from. Okay, so I'm going to use 0, 0. And so on this graph, I can tell that this the transformations are, it gets shifted right 2. Remember, H lies here, right? H is actually positive 2. And then K is positive 1, or in other words, the graph gets shifted up by 1. So that, that reference point here is going to get shifted right 2 up 1. Okay? And just like in the parent function, what happened here and here on the x and y axis, which of course intersect at the origin, those are the lines that the graph didn't intersect. So I'm going to go ahead and draw those. Now, what these are called, these have a special name. These are called asymptotes. We've seen these before. We have a vertical asymptote and we have a horizontal asymptote. These are these lines that a graph approaches but never actually intersects. Okay, I think of the graph as sort of avoiding those lines. It's like, I'm not hitting that, I'm going to turn away. But it gets closer to them, but never quite intersects. So basically what we've done, we've taken, the asymptotes here would have been the y-axis and the x-axis. We've taken those asymptotes and shifted them based on the transformations, and that'll help us get the rest of the graph. Okay, looking at that, those are the only transformations. There's no stretch, there's no reflection. So we basically just use some of these as reference points, and I would probably pick this one, and then it would be good to have these 3 basically, or actually 6, okay, but it's sort of 3 on each piece. So let me kind of go a little back and forth here. So first of all, what this tells me to do from that center point is go left 2, down 1/2. So I'm going to do that here, left 2, down 1/2. Okay, and then left 1, down 1, left 1, down 1. Left 1/2, down 2, left 1/2, down 2. And so we're going to sort of get this graph that looks like this. The asymptotes really help out as you sketch a graph. So there's part of the graph, and now we just do that with the other reference points. It's going to be from this, what you would call the intersection point of the asymptotes. You're going to go 1/2 to the right, and then up 2. So 1/2, up 2, right 1, up 1. Okay, and then right 2, up 1/2. All right, and then there's our graph with the asymptotes shown. The other thing we're asked about here is to identify the vertical and horizontal asymptotes. How do we write those down? Well, so the vertical asymptote, which I'm just going to abbreviate VA, that is this line here. How you write that down, you have to write it down as an equation. How you indicate a line, how you reference a line on a graph, it's with an equation. So and a vertical line is a special kind of line. It doesn't fit in the mold of y equals mx plus b. It's the only one that's x equals. So it's x equals 2 here. Basically, every x value on this line is 2. The horizontal asymptote is right here. that's going to be y equals 1. Or in other words, every y value is 1 on there. Or you could think of this one as y equals mx plus b if you wanted to. Yeah, y-intercept of 1, no slope. And then the domain and range. Yeah, this is going to look quite a bit different than other graphs. So if we look at this, going from the left to the right, domain means what x values exist on this, right? So it goes all the way to the left, so that means it's going to start at negative infinity, but then it stops, there's sort of this gap here at 2, right? At an x value of 2. So we say that it goes to 2, and then it doesn't actually touch it. That's why you use the parenthesis, not the bracket. And then leave a little space here for now. And then it picks up after 2, right? Because here it picks up after 2, and then it goes to infinity. And how do you say, okay, it's these two things together? Well, you use this symbol called a union symbol. You might have seen that before if you've used set notation before. So this is how you write down the domain. And this is the way to sort of say it includes all numbers from negative infinity to infinity, but it sort of skips over 2. It does not include 2. All right, and it's a very similar thing for the range. So again, bottom to top here, possible y values. It goes down to negative infinity, and then it does not hit y value of 1. It stops at 1 and then picks up after, or stops just short of 1, I should say, and then picks up after a y value of 1, and then goes right here, and then goes to infinity. Okay, so that's what the domain and range look like. All right, why don't you guys do actually I'll do number 3 with you because we have a stretch here on this one. Okay, so number 3. Let's think about what the transformations are. Well, we have a vertical stretch of 2. So notice this vertical stretch shows up here. You could write it in front, but you can also write it on top of the fraction. So yeah, vertical stretch of 2. And then we have it goes up by 1. So, and that's it. So we're going to first move our asymptotes. Remember, the asymptotes are normally for the parent function are the y and the x-axis. So we're going to shift those up 1. So, so one of the asymptotes stays put right there. The other one is going to be going through 1 here, right? Okay, so there's where our asymptotes are. We've shifted them up from the origin up 1. Now we think about these reference points, and I might just write them down here. Okay, so we have these reference points, and so now we're going to plot them, but we also have to factor in this stretch of 2, okay? So basically what that means is all of these vertical values are going to get multiplied by 2 here. Okay, so this tells me left 2, down a half, but now I need to multiply that by 2, which would be a negative 1, right? So I'm going to go left 2, down 1, and then left 1, down 2. Okay, if it helps, you could write down all of these times 2 first, if you wanted to, just to kind of help you out. All right, so we're just the result of those being multiplied by 2. It's a vertical stretch, right? So that's why the vertical value, the y value, gets multiplied by 2. All right, so left 1, down 2, and then left a half, down 4. So like that, okay? So that'll look like that. And then on the other side here, right a half up 4. I almost said up 2. It's right here. I missed it. I accidentally went to 4, but I have to count 4, right? So right a half, up 1, 2, 3, 4, which actually ends up at a y value of 5, right? And then right 1, up 2, and then right 2, up 1. So all of those vertical amounts are getting multiplied by 2. So we end up with that. All right, and then we need our other values here. I'm going to let you do this part, okay? So go ahead and do this. Identify the asymptotes and find the domain and range on your own. All right, so I got a vertical asymptote x equals 0, which that's basically the equation for the y-axis. And then the horizontal asymptote is y equals 1. Domain, yeah, negative infinity to 0. And then 0 to infinity, basically it just skips over 0. And then the range skips over 1, right? So that's that. All right, let's do number 4 together. So this one we have, we go right 4 and then down 1. And then this time we have a reflection over the x-axis. Okay, so we need to shift those asymptotes from the parent function by these amounts. So we're going to go right 4, down 1. So there's where the asymptotes are going to intersect. So we draw those, and that'll help out quite a bit. And then we think about those reference points. And yeah, you can go back and look at them. I might need to. Okay. And of course, you know, with all these, you can use a graphing calculator to assist. And you can use the table on a graphing calculator. Keep in mind the table is not going to show you this value, so you might want to have it step by 1/2 on your table setup. Okay, so here we have this, and now we're going to go left 2, and instead of going down 1/2, we're going to reflect, so we're going to go up 1/2. Left 1, up 1, and then left 1/2, up 2. If you'd rather, write down the opposites first, you could do that. If that was confusing, you could just like make yourself a note here. Oh yeah, I'm doing the opposite of all these. Okay. All right. So there's that piece, and then on the other side here, we're going to have right 1/2. Down 2, right 1, down 1, and then right 2, down 1/2. So we have this and this. One graph, 2 pieces. Okay, and then horizontal asymptote. Let's see, did I do the vertical asymptote first on the other ones? I better stay consistent here. All right, yeah, the vertical asymptote and horizontal asymptote. So vertical asymptote is 4, x equals 4. Horizontal asymptote is -1, right? And then the domain, well, it's going to be skipping over 4. So you've probably seen a pattern here. It's pretty much always going to look this way. It's just that number that it skips over, or this number here will always match that number here. Be careful with that shortcut though. And then the range goes from negative infinity to -1 is what it's going to skip, right? So there we go. All right, you guys do number 5. All right, so here's my answer for number 5. Little trick here, we had a vertical stretch by 4, reflection over the x-axis. That means we're multiplying by each of the vertical amounts by -4. So I did that and sort of wrote that number over here to help out. That really helped me think about it. And yeah, so I shifted my asymptotes based on the translation amounts. And so like one of my points, for example, was left 2, up 2. Another one was like left a half, up 8. One of the points I couldn't graph, so that's the one I lined out here. I couldn't go right half and down 8. And then there's everything else.